So the first question is pre-order traversal in an iterative manner. Right. So mm, first I'll draw the tree. Oh man. So what I have here is a tree now. Right? Wait. Where the heck is it? Hmm. So what I have here is a tree, and we are supposed to find the pre-order traversal of it, and we have to do it iteratively. Hmm. So we all know that for depth first search approaches, traversals, we have to use a stack. So boom, I've created a stack which is a LeFo data structure. Then and pre-order would mean that the root would appear first, then it would be the left node, and then the right node. So if I was to, sort of make a pre-order traversal of this tree right away, I would say that it would be 8, then 1, then uh, left, and then 7, then 10, then I would go to right now, then 5, then 10, then 6, then again 6. Okay, so now how would I do it with a stack? So let me erase this LeFo thing away from here. So the first thing that we're going to do is we're going to take the root and we're going to put it in the stack. Okay, now what we're going to do is we're going to check for the left node and the right node. Then we enter. So but for that we'll first have to pop this thing out, and then we push the first and then the fifth, rather the left node and the right node of this node. Okay, so now this 8 is outside, has been popped, and it does not exist anywhere in the stack. Right, so let me take it out of here. So what we did was we first pushed in the 8, the root node, and then we took its neighbors, uh, which is 1 and 5, and we pushed them onto the stack. And also as soon as we popped it, wait a second, where is it? And as soon as we popped it, our output was pushed with 8, or the node which was recently popped. Okay, now the stack has 1 and 5. mm, and till the time this stack becomes empty, we will repeat this process. So now the root is 1, we will look at the left, which is null, so we don't need to push anything. And then we'll look at the root has already been printed, so we'll pop this. Okay, because we need to first take in the root, right? So we pop this root, we add it to the answer queue, and then we look for the left child, which is null, so we don't push anything. We then look for the right child, which is 7, so we push that onto the stack. Okay, uh, actually wait, I've done something wrong. Wait, I've done something wrong. Okay, this is not how it happens. Wait. We popped 8, and then we pushed it to the answer stack. We then pushed 5 and 1. No, we need to do we need to first push. Okay, fine. So actually we first need to push in 5, and then we push in 1. Okay, and after that we look at the topmost element and we pop it, and we push it to the answer queue. Okay, so now 1 is gone away, and we push the neighbors of 1 onto the stack. So the neighbor of 1 is null, so we don't need to push it. Then the next neighbor is 7. So we push 7 onto the stack. Now we look at the neighbors of, now we pop 7 and we look at the neighbors of 7. So in this case, the neighbors of 7 are null. Where did it go? Null and 10. So we first pop 7, we add it to the answer queue, and we push in the neighbors of 7. So we push in null. We really don't need to push in null, but then we push 10. Okay, and then the neighbors of 10 are null and null. Okay, so we don't really need to push anything. So now what we do is we pop the stack again. We pop 10 again. So that goes away, and we push it to the answer queue. And since it does not have any neighbors, we don't need to push anything. We don't need to push the neighbors of 10, which are null and null. So now we move to 5. Okay, now the left subtree has been completely printed. We first had the root, then we had the left of 8 of root basically. Now we'll move to the right of root, right? So we have 5. Now we'll pop 5, okay, and put it onto the answer stack. Oh, sorry, the answer queue, the array list, and we will push in the neighbors of 10. Push in the neighbors of 5, which is 6 and 10. We need to keep in mind the sequence in which we push. Okay, we need to first put in the right neighbor and then the left neighbor. It is so because we need the elements in. Oh my god, wait. It is because we need the elements in root left, right, and stack would print the things in reverse, right? So we need so if we push in right first, we'll get right at a later stage. So if the latest element which was pushed was the left element, we'll get it. Will basically the answer queue will get the output of uh, the left node before the right node. Perfect. Uh, so now, so now the stack has a 10 on it. Now what we do is the stack is again not empty, right? So we pop 10 and we put it onto the answer stack, and then we push in the neighbors of 10, which are 6. Okay, 10 has only 6 and null, so we don't really care about null again. uh, so now we have reached till 6, right? This 6 right here. So now we'll again check for the neighbors. Now we'll pop 6 and push it onto the answer stack. Now this has been popped. Now we'll look at the neighbors of this 6. So they are null and null, so we don't need to push anything. Now what we do is we go to 6. Now we take this 6 and we pop it and we push it onto the answer queue, answer array list, whatever it is. Okay, and we erase it. Boom. So now that the stack is empty, we don't need to do anything. And this is our answer array list. We will output this and return it to the function which the question asks. So if I wait a second, I hope it was visible. So now it's time to code this thing up. Okay, you can look at this example. No need to really look at it. Um, yeah. So now I'm going to code it up. So what the question asks of us is, we need to return an array list, right? So we first create an array list of integers, and I'm going to name it answer. It's a new array list. It's a new array list. Wait a second, let me go into full screen mode. It's a new array list, and the node, wait a second, if root equal to null, will simply return the answer. So if basically the root is null, so if it's an empty tree, right? A tree without any nodes will directly return the empty list, right? Because there won't be any pre-order traversal. Now, I said that we need a stack, so we'll create a stack, and this stack will contain nodes. Okay, node is basically the node of the tree, right? So, and what we do is we initially push the root onto the stack so that we can begin the traversal, right? Pre-order traversal. We need to have a root, right? So while st dot while the stack is not empty, we're going to do the following actions, right? So what did I say? First, we're going to um, pop this thing, right? So node, you could say node is equal to st dot pop. Okay, first we're going to pop this thing. Now we're going to add this to the answer queue, answer list. It's not a queue, it's an answer list. Answer dot add node dot data. Okay, now we check whether this node which we have just selected has a left neighbor, has a left child or a right child. So if node dot right not equal to null, so basically what we're going to do is we first check whether there is a right child or not, then we check whether there is a left child or not. Why? Because we need the output to be root left right, no? So if I push in the right child first, I'll get the if I push in the left child first, I'll get it before the others, right? So st dot push node dot left. So basically, if we push in the left child first, we'll get it outputted before the others, right? If node dot right not equal to null, st dot push node dot right. Okay, so we have done this node dot right, um, and yeah, this should work. Mm, st dot pop answer dot add. We have created the node. We have pushed it into the answer list. Then we go to the left child. No, wait, yeah. What the heck am I doing? This right needs to be pushed before. So yeah, this should work. Now if I compile and run, so problem solved. Now we move on to InOrder traversal. Oops, I need to explain this, right? So now we're going to look at InOrder traversal, right? Wait. Now we're going to look at InOrder traversal. So again, we have a tree whose InOrder traversal is required. So we have 8, 1, 5, 7, 10, 10, 6, 6. Okay, you get it. This is the right child, this is the right child, this is the left child of 5, this is the left child of 10, this is the right child of 5, this 6 right here. And these two are the left and right children of 8 respectively. So again, it's a depth first search traversal, so we're going to need a stack. And now, okay, wait, for InOrder traversal, we're going to need the output should be in the form of left. We're going to need the output in the form of left, root, and right. Okay, okay. So for this, what we're going to do is, mm, hmm, hmm, hmm. Till the time node is not equal to null, right? So we first need to push in all the left nodes, okay, and then we can maybe think of pushing the right nodes in. Okay, fine. Let me first code it up and then I'll think about it. The solution. Where is it? Hmm. What will I do is I'll create an array list of integers, call it the answer. What am I going to do is create an array list of answers. Then, if it is an empty tree, return answer. Then, of course, because it's a DFS traversal, I'll need to create a stack. St equal to new. Now, hmm, okay. So till the time, so we need the left node first, right? So till the time um, node is not equal to null, we push node dot left onto the stack and we move to the left. Hmm. Move to the left if node is not equal to null. Now that it has reached null, what we'll do is we should be looking to mm, hmm, hmm. We should, now that we have reached null, we should be looking to move to right after adding the answer, after adding the left node to the answer, right? So um, after we have added it, now what we do is st dot push node dot right and the node equal to node dot right. If but if the stack goes empty, we'll need to break, right? So if st dot you break, but wait, we'll first need to pop it, right? Mm, let's see if this runs. Mm. मैं किसी का बनाऊं तो काम कुछ ओके seems like wait a second यार okay fine, so you post it and it became null. Now we need to add the node.data to hmm, hmm. प्यारा सोच माता रहूं सच अब सबके सामने सच ना करो तकरीबन मेरे हेलीकॉप्टर मैं करता रोज डोरे Cause I'm a bad ass performer. Oh wait, not the swag, bad ass performer. Cause I'm a bad ass performer. Oh, yeah. Wait a second. So we push the node. Now what we do is, अरे यार, we push the node. Now we move to the left. Okay. Now what we do is, now that it has reached null, mm, well, let me try this. Mm, mm, nope, no. Wait. It's giving a null pointer exception, right? Node equal to node dot left करते रहो, and then what we do is go to stack dot pop. So we will have to add the answer, then we push the right of that node, and then we move to right. I don't think this is wrong at all. Wait, let me check. Okay, let me check, man. Let me check. Let me check. जिंदगी सवार तू एक नई पहाड़ तू बनाना तो प्यारा सा चमत्कार वो मैं किसी का गाना हूँ जो आज बन चुका है सच मेरा ज़माना है कि कभी wait, what? So I don't need to push the right. Even yeah, helicopter. Ah, ah, ah. Oh, it will follow you. Shit. ठीक है fine, you live you learn, है ना? Stakes one, man, stakes one. If we submit this will pass all the test cases. Oh my god, true. Whoa. Okay, fine. So let me understand the code and then I'll explain it to you guys, whoever's watching. If node not equal to null, hmm, else okay, fine, I'll try to explain. Hmm, hmm. So hmm. So what we did was we assigned node to root. We took a node and we assigned it to root. So this is where node is. So now while while the stack is not empty, till the time the stack is not empty, what we do is we check if node is equal to null or not. So definitely node is not equal to null, right? It's 8. It's pointing to 8. So we move. So what we do is we push this to the stack and we move to left. Okay, so now node is over here. So now is node equal to null? No. And what we do is we push 1 to the stack. Now we move node to left. It's null. So what we do is we uh, move to right. Okay. But before that, what we do is we pop this 1. Okay. So now once this 1 gets popped, and we add this to the answer list. Okay. We add this to the answer. Mm, so we add 1 to the answer, and what we do is as soon as 1 is added, then we move it to the right. We move node wait a minute, we popped this 1 and then we moved to so node became 1 again. After this node became null, what we did was we went back to the node at the top of the stack which was 1, and then we moved to the right of the this particular node. So now that we had 7, we'll push in 7, and actually we won't be pushing 7 right away. Okay, so wait. Mm, and what we did was we added the answer to the uh, 1 to the answer, and we moved node over here. Okay, that's it. Now the program will again check whether this right here, while true, if node is not equal to null, what we do is we push it onto the stack. So we push 7 onto the stack. Now node moves again to null. Okay, uh, now that node becomes null again, we'll push the top of the stack and we add it to the answer list. Okay, and we move to the right of 7. Right, node is equal to node dot right. So now node is pointing to 10, or rather node is equal to 10 in other terms. Now what we do is well, as soon as if node is not equal to null, what we do is we push it to the top of the stack, and then we move to left. Left is again null, so we move back over here, and then we pop 10 and add it to the answer list. Mm, so now so now this is the case, right? So now again um, okay, so now what happens is node moves to left, sorry, node moves to right, and the node is now null, है So what we do is, now that node is equal to null, we will uh, take this node again, right, and we'll pop it, and we'll add it to the answer queue, answer list. We'll add it to the answer list now, and we'll pop it. And now what happens is we add the right, and node will move to the right of 8, right, because this was the root element, right, and we are supposed to move to the right of node, so we'll push in 5, and then what we're going to do is it will again check whether node is equal to null or not, and because it is not, it will uh, basically push 5 and then move to the left. So now node is here. Is node equal to null? No. So it will again push 10 now, and it will move to 6. Is node equal to null? No. So it will move. So it will push 6, and it will move to the left of 6. So now the left of 6 is null, right? So node is equal to null. So what will happen is it will now start popping. So this 6 will get popped, and it will be added to the answer list. Okay, it will be added to the answer list now. And then node will be moved to the right of node. So is right of this 6 equal to null? Yes. So what will happen is we will again pop this node, right, and we'll add it to the answer list, and this will get popped. And now what we'll do is will move node to the right of this 10, which is again equal to null. So what we'll do is now we have popped this thing, and so now we'll go to 5. Okay, and we'll pop 5 now and add it to the answer list. and it will move to now it will move to right. Whoops, now it will move to right, and it will add this. Now these two are null, so it will add this to the answer list, and the answer becomes 1, 7, 10, 8, 6, 10, 5, 6. So this was the InOrder traversal. Okay. Now we're going to look at the post-order traversal. Again, let me draw the tree. 8, 1, 7, 10, 5, 10, 6, 6. So post-order would mean left, right, root. And there are two algorithms for finding out the post-order traversal. We're going to use the two stacks approach, basically. Uh, and I'm going to get to the complexity, time and space complexity of these algorithms later on, after I do the traversal. Okay, so where were we? Wait a second. So now again, because it's a DFS, we're going to need a stack. Okay, and interesting. And basically, we're going to have two stacks in this approach, but we'll get to the second stack later on. Oh no, wait, we'll have to get it over here. So we'll need two stacks, and mm, let's say we have declared an array list. We have declared two stacks. So now till the time stack 1 is not empty, what we'll do is we'll push root. So we'll push 8 to the stack 1. We'll push root to the stack 1, and till the time it is not empty, what we'll do is we will have to push the we'll have to push the if I'm pushing the right one, pushing the right. So we're pushing the right node. Okay. So what we'll do is we'll pop this and no, wait. Okay, fine. Again, I'll write the code and then I'll think about it. Okay, wait. Mm, Okay, fine. So mm, what will add? Huh? st dot pop. This is what I'll add now. Oh wait. To find myself again, my walls are closing in. I felt this way before, so inception. Calling my skin. These words they will not you. Oh, God uses what is real. Calling these words they will not you. God uses what is real. Oh, whoa, 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 man. Consuming reacting to find myself again. My walls are closing in. Calling my skin, these rules they will not be fair as all like one that use and was real. Okay. Hama. Wait a second, Bob. Okay. My age is changed. I plus the front game. I think I should get. How many more days can I wait? I made plans with you, and I won't let it fall through. So while the stack one is not empty, what will I do is I'll first pop this element, okay, which was root, basically the whichever element is on the top of the stack, and then what I'll do is I'll push in the left of the stack if it is not empty, then I'll push in the right of the stack if it is not empty. So 1 and 5. Okay. Now, and what I'll do is I'll add this root to stack 2. Okay. Now, mm, now again this 5 will get popped. Okay. 5 gets popped, and the left of 5 gets added. Then the right of stack gets added. Of 5 gets added. So these two elements have been added. Now 6 gets popped. Oh, and wait, 5 is then added to the stack 2, and 6 gets popped. So now that is added, and then its left and right are added. So there's nothing. So that's null. Now what happens is uh, 10 gets popped, and it gets added to stack 2, and then its left and right are added. So they are, wait, so they are 6 and 10, right? Mm. So wait, no, that's 6. So now 6 gets added to the stack and it gets popped. Mm. Now we are left with 1. Now 1's left is null and 7 gets added, and then 1 gets added to the stack 2. Now 7 gets popped, it gets added to the stack 2, and then the left and right of 7 are added. So left of 7 is null, and then 10. Then 10 gets popped, it gets added to the stack 2, and then left and right are added, which are null, and then 1 gets popped. So, and now this gets popped and it's added to the answer list 1. So when this stack 2 gets popped, it will be 1 1 will be added to the list, 1, then 10, then 7, then 1, then 6. Wait a second, there's two ones. No, wait, this one is not there. Okay. 6, then 10, then 5, then sorry 6, then 5, then 8. So this should be the answer, right? Now we'll move to um, what the heck. Fine, I've gone wrong, but I know how to do it. I'm just unable to explain it. Okay, this is a practice stream. So now I'm going to exit this. Okay, I don't have enough time. My mom just called me, and finding the height. This is a BFS problem. Mm, what we're gonna do is, so wait a second first. Mm, जब life so out of control, हाँ, so now what we're gonna do is, this is survival of the fittest. This is do or die. This is the winner takes it and also take it all. Mm, done. So this was a pre-order, in order, post-order, and then level order, which first we were DFS traversals, and the last one was the BFS traversals. That's it for the stream. First stream that has gone on for so long.